on YouTube. And we've got a few attendees here already. Welcome, everyone. We're so glad to have you with us again. It is Wednesday evening, and we're getting started on YouTube for those people who would prefer to join on YouTube or have trouble joining on Zoom. Welcome, everyone. It's time for us to get started. We're so glad to have you with us. My name is Christine Shupla with the Lunar and Planetary Institute, and there's a variety of people with me. I'm going to go ahead and start sharing a screen, and while I'm doing that, Andy, please introduce yourself, and please allow the others to introduce themselves as well.
Hi. Sorry.
Hey, all right.
Actually, we will have someone else start. Lori, please start introducing yourself.
My name is Lori Pig. I'm a microblogger at LPSC. I'm also a PhD student at Northern Arizona University and a Pathways intern at the U.S. Geological Survey Astrogeology Science Center. Most of my research is in lunar volcanology.
Thank you so much, Lori. Martin, can you please go ahead and go next?
Sure. My name is Martin Majowski. I'm a microblogger at LPSC. This is my 4th year to do microblogging, and I still count last year. And I had a great time. I've had a great time all week, and already I'm thinking, like, let's see. So after tomorrow, there's only one more day of this, and so it's fantastic.
Thank you so much. Shogo, would you please join us and please introduce yourself?
Yes, my name is Shogo Tachibana from University of Tokyo, and today I'm going to talk about the Hayabusa 2 mission, and then I'm now connecting from Japan.
Yes, so you're doing an extreme duty, joining us in early morning for you. So thank you so much, especially after a long night. Before I go further with introductions, I'm going to pause here. Several of you probably are noticing the words, the captioning appearing at the bottom. You have the ability to turn off the captioning if you find it distracting. There's a little button for captions, and you can turn it off by telling it to turn off the captioning. So I think there's another word for it, but please do so. Also, please, for all of our participants, use the Q&A box to enter questions, use the chat box to share your thoughts, and please select all panelists and all attendees so that other people can see your comments as well. We are recording this, and we are also streaming it live on YouTube. Let me go ahead and we're going to go here to tonight's panelists. Renee, please introduce yourself.
Hi, everyone. My name is Renee Weber. I'm the chief scientist at NASA's Marshall Space Flight Center in Huntsville, Alabama. And I gave a talk at LPSC today about the agency's Artemis missions and about doing science on the moon. I'm also a planetary scientist with a background in lunar and Martian seismology.
Thank you so much. I don't know if Xinting is here. Have you joined us?
Yes, I'm here. Sorry, I just had a very long meeting.
Absolutely. Please introduce yourself. Thank you.
So my name is Xinting Yu. I'm currently a 51 Peg B postdoc fellow at UC Santa Cruz. I study mostly Titan, Saturn's biggest moon, and exoplanets. Yeah, that's pretty much about me.
Thank you so much, Xinting. And Andy, please introduce yourself now.
Oh, I'll try. My name is Andy Shaner. I'm with the Lunar and Planetary Institute in Houston, and I'll be here this evening just helping out as needed.
Thank you so much, Andy. I appreciate it. Yeah, it's tough for all of us who are working from home, especially during busy times like a conference. I'm going to go back just a tiny bit here. LPSC, for anyone who's joining us for the first time tonight, this conference is held annually in March. This year it's virtual, and we bring together international specialists in a variety of sciences to present the latest planetary research. And here's the website, but all you need to do really is just Google LPSC to find out more about it, or the Lunar and Planetary Science Conference. And the abstracts of all of the presenters are available online, and you can look them up yourselves publicly. So we are going to be, before I do that, I'm going to pause here for just a second. I am going to stop sharing so that we can go ahead and poll our audience. I'm going to allow our panelists to vote here as well, but we'd like to know a little bit more about you, your own background and interests in planetary science. And this question is a little bit similar to the past few nights. There's one difference here. If you're joining by YouTube, you might not be able to see this, but choices include whether you're curious about planetary science, whether you don't know much but would like to know more, whether you enjoy learning about the solar system. Are you studying planetary science? Are you a solar system ambassador? Are you an amateur astronomer? Are you, in fact, a planetary scientist yourself? Are you attending the LPSC conference? Or are you being forced to attend this against your will, possibly by a family member, a spouse, or an educator? Anyway, we're glad to have all of you. I'm going to give everyone 5 more seconds to finish voting. And 4, and 3, and 2, and 1. Well, we've got a big variety of people, but so far right now, most of you who are attending via Zoom are actually attending the conference. That's fabulous. We have people who don't know much and would like to know more. We've got a big variety, as you can see. So we're glad to have all of you with us tonight. That being said, we're going to go ahead and get started with the first thing we're going to do tonight is we're going to hear a little bit from Dr. Renee Weber. I'm going to have some questions for her, and but while I'm asking her those questions, I'm going to show some pictures. And if others are adding their own questions, please do so in the Q&A box. And Andy, please feel free to interrupt at any point if you see a question either from YouTube or from the Q&A box for Dr. Weber. So let's go ahead and let's start sharing some pictures here for Dr. Weber. So here there was a report at this conference about the Artemis 3 science definition team. Renee, could you please go ahead and just tell us a tiny bit, what is the science definition team? What is that?
Sure. So NASA puts together science definition teams when formulating new missions, both for robotic missions and for human missions, to help really develop the big picture motivating science questions for the mission. So of course, one of the primary purposes that we're going to the moon, that we're doing these exploration missions, is to learn and to do science. And, we, the Artemis generation, aren't the first people to have thought about what types of questions should we ask and what types of experiments should we do. And so the science definition team was pulled together to bring together a really diverse set of science expertise from across the agency and from across the broader scientific community, to pull from the incredibly rich resources that we have in our knowledge of the moon and figure out what the remaining unanswered questions are, and then prioritize those questions so that as the missions move forward in their planning, we know what types of instruments we need to send and what types of samples we need to gather and what types of investigations we can do on those samples when we bring them back to Earth. And so that was really the purpose of the science definition team.
And for anyone who might be a little bit less familiar with Artemis, and it's probably evolved a little bit over the past few years, can you tell us a little bit more about these plans to return to the moon?
Yes, so Artemis is the agency's current plan for human exploration, which focuses on both the moon and Mars. and really puts together a plan for returning humans to the moon by 2024 currently. And it's got a lot of different aspects. I didn't include what we call the swoosh chart in this presentation, but there are orbital assets, which is it's called the gateway. You can think of it as sort of like an International Space Station, but it's in orbit around the moon rather than in orbit around the Earth. There are landed components that are both robotic, so small robotic landers that carry science instruments and land all over the moon. And then, of course, the human missions starting in 2024 and building towards a sustained human presence on the moon to set us up to one day explore Mars with humans.
Awesome. Thank you. Thank you. And so that was a little bit about Artemis. And here in this picture, of course, I can see an astronaut standing on the moon and sifting through dust. And there's something kind of foggy in the background. Can you tell me a tiny bit, what sorts of things might people be doing on the moon, and what sorts of science are we looking for here?
Sure. So yeah, the thing in the background is the Human Landing System, or HLS, which is one of the primary components of the Artemis program, just the spacecraft that actually brings astronauts down to the surface. And then once they're there, the plan right now and the outcome of the Science Definition Team report was to put together this sort of campaign of experiments that will take place on the surface. Right now, the Artemis missions, the initial missions, are planned to last for about 6.5 days. And so over the course of those 6.5 days, we recommended a variety of activities that the crew will actually do when they are on their EVAs or, in their spacesuits out on the surface. So gathering samples is obviously a really big one. We want to pick up as many different types of rocks and soil as possible, including the possibility for a volatile bearing sample. So the Artemis missions are going to the South Pole of the moon, where we know that there are increased deposits of ice, and ice and water are very important sort of assets to have access to when you're thinking about sustained human presence. Not only because water is necessary, we need water to drink, we can use water to make air to breathe, we can also use water to make to make fuel to fly. And so it's sort of one of the big factors in the decision to go to the South Pole is because of that presence of water. So hopefully we'll be able to gather samples that help sort of provide some ground truth for the measurements that we have taken from orbit on the distribution and abundance of water ice. And then, so samples is a big part of it. The second part is deployed experiments. So on the Apollo missions, there was something called ALSEP, which was the Apollo Lunar Surface Experiment Package, and had a bunch of different types of instruments that were designed to be sort of turned on and then left on and continue to record data after the crew returned home. And then finally, the third type of experiment is what we call in-situ experimentation, or really doing field science. When crew may have a handheld tool, a handheld instrument, sort of, one example might be some sort of handheld spectrometer that you can use for compositional information in the field, which can help provide context for the samples that are being gathered. Another example, really obvious one, is a camera. Obviously, we want to be able to take as many pictures as possible, going to a place we've never been before, and also to provide context for the samples that are gathered and for the deployed experiments. And so those are sort of the three main components of the types of activities that we hope crew will be able to do on the surface.
Awesome. Thank you. Andy, has anyone chimed in with a question or anything? I'm going to just skip past. Well,
no, not yet.
Not yet. Okay. It looks like you've got a great group of people here on this committee that we're coming up with some of the science. Is there anything briefly that you want to say here about who's participating, Renee, or shall we continue?
Yeah, so we had a really great team. This was a short turnaround activity that we executed over a period of about 4 months. We had members from across NASA. We had several community consultants that represent really large groups of planetary scientists and other experts. One is called the Lunar Exploration Analysis Group. Another is called SURVEY, the Solar System Exploration Research Virtual Institute, and also CAPTEM, which is now called XMAG, that Extraterrestrial Materials Analysis Group, which is where all of the lunar sample curation decisions are made. And all of these people really contributed, and I had just the extreme privilege of working with them.
Awesome. Thank you. I'm going to skip over this, and I'm going to skip over this. And so here it talks about some of the different priorities that Artemis laid out, and the science objectives based on those priorities. Was it difficult to try to narrow down your science priorities with this group of people, with all the different things that you could be doing? Was this a difficult process?
Yeah, I do think it was difficult, but we had it was a sort of a logical process that we followed that made the difficult task manageable. And fortunately, we had a lot of existing documentation and strategic planning to pull from. In fact, if you go back just one slide, we started with a handful of roadmaps that already exist, that were written over the years by members of the planetary science community, by experts who have been working on Apollo data for 50 years, and who really have a grasp and a community consensus on what outstanding questions there are. So we started with these documents, so we didn't have to start from scratch. So that made a big difference.
Awesome.
And these
got
are
a
all
question.
publicly available reports, and they're available on the web for anyone who's interested in reading them.
Thank you. Andy?
Yeah, we had a question came in online. Although NASA is interested in the lunar South Polar region, is there any consideration on sending a crew to the moon's North Polar region?
Yeah, so I'm sure that I know that the South Pole is not the only potential landing site. As you move forward in the Artemis program, and there are more and more missions, there is the potential to go to other locations. Whether or not that includes the North Pole at this time, I'm not sure. I do know that on the robotics side, through the Eclipse program, the Commercial Lunar Payload Service program, small robotic landers are currently planned to go to a variety of globally distributed sites. One thing I will say is when you do start thinking about building towards the sustained human presence, there's sort of the requirement that you go to the same site multiple times so that you can build up architecture over the course of time. But future missions, I do think, are open to other landing sites.
Awesome. Thank you. I'm just going to move ahead here. You know what? There's so many awesome things about this, and we're going to have a lot of questions and discussion about it. But I'd also like to make sure that we get to Dr. Tachibana's presentation. So what I'd like to do right now is pause on this one. And Dr. Tachibana, would you care to share your presentation now? And then we'll talk about Artemis and the science objectives and Hayabusa 2. And we'll talk about everything else that's been going on today.
Can you see my screen?
We can see the screen, absolutely. Oh, it looks beautiful.
Okay. Okay, so I'll be talking about the Hayabusa 2 mission, and especially capsule retrieval operation and sample opening operation, and also what we saw inside the sample container. Okay, so you may know the mission, but Hayabusa 2 is the mission to return pristine asteroidal surface samples from a C-type asteroid Ryugu that may record the long history of the solar system. And Hayabusa 2 found many things at Ryugu, but I just focus on the sample collection. At the surface of Ryugu, Hayabusa 2 shot a projectile onto the surface, and under the microgravity condition, the ejector particles are supposed to be stored in the sample canister. And these are the images taken during landing operations. We did landing twice at the different sites of the surface in February and then July in 2019. And we confirmed the firing of the projectile. And so I will talk about the capsule retrieval. Hayabusa 2 safely back to the Earth in December. So last year, and then this is the trajectory of the re-entry capsule fireball. And we did this operation in South Australia. So using this building in Lunar test range, we built so temple clean lab there, like this. And after installation of this space, we made several rehearsal operations and waited for the return of the capsule. And here's a short video that JAXA made. It's South Australia. The operation team consists of 70 scientists and engineers. And so they are now setting up the antennas to detect beacon signals from the capsule. And we also use drones to find the capsule and the parachute as a backup. And so this operation was made as a very close collaboration with Australia. And here you see the fireball of the re-entry capsule. It was 4 a.m. on December 6th. And after we saw this fireball, we flew to the place. Okay, so now they are excited about the detection of the beacon signal. And we flew to the landing location, and then here is a parachute, and the capsule was sitting next to the parachute. And we found the capsule and made some security operation and then transported it back to the quick look facility. Yeah. And so we cleaned up the container and made some treatment to extract volatiles inside the container. And after all the operations, so we flew back to Japan from Australia. So everything is securely packed in this transportation box, and we flew with a capsule from Umera Desert. Okay, then so on December 8th, we started working to prepare the container opening in a vacuum chamber. Here you can see how busy it was. It took 3.5 days to finish all the preparation, but it went quite smooth because we did many rehearsals for this operation. And finally, okay. Yeah, so we installed the container to to this clean chamber system where we open the container. Actually, today we have I have the replica of the sample container. So we opened this container in the vacuum chamber and then and also took off this part of the sample canister, and we saw many dusty, so dark particles. The maximum size, largest size here was about 5 millimeter. And we also found so centimeter sized pebbles in a different chamber we used for the second touchdown. And these are all the particles found for the first touchdown location. And this is the samples from the touchdown 2 location. And so we found particles in 2 separate chambers. So that indicates samples at different surface locations were obtained. And then particles were really black, consistent with the color of UV borders. And centimeter sized pebble is actually close to the maximum obtainable size. We're happy with this. and the total weight was more than 5 grams, which is far more than the mission requirement. So I'm glad to say that our system worked efficiently, and the sample collected looks very well representative of UGOO. So in summer, we're gonna start sample analysis to explore the long history of the solar system. So more will be soon. That's all. Thank you.
Thank you. So, so congratulations. Yes, Bill pointed out, congratulations to you and JAXA and your team. This is amazing. Folks, now is a great time for you to start asking questions of both of our speakers. We'll take a few minutes of questions about the Artemis Science Definition Team and about Hayabusa 2 before we continue on to a general discussion of the day. So please enter your questions in the chat box. Actually, enter your questions in Q&A, and please add your comments in the chat box so everyone can see your comments. We'd like to hear from all of you. And while you're doing that, let's go ahead and bring up another poll while you're thinking about that. So while you are thinking about that, I've got a question for all of you, including all of our panelists. So if you could visit someplace else, a moon, the asteroids, a planet, where would you go? And you can do multiple places. Would you start with going to the moon, or with Mars, or with an asteroid? Maybe, probably not, absolutely not, or yes, but someplace else first. And please enter those other objects that you would like to go visit in the chat if you can. Where would you go if you could go anywhere? And so, yes, Ken says Europa is the first place he would go. Awesome. While we're here, Lori, if you could go anywhere, where would you go?
I'm a lunar volcanologist. I would go study my volcanoes.
You would study volcanoes on the moon. So Shogo, where would you go if you could go any place in person, or would you?
So we just came back from the asteroid. So I'd like to go to a comet.
You'd like to go to a comet. So, okay.
Yeah.
Okay. Renee, how about you? Where would you go if you could go anywhere?
If I personally were faced with a decision to go into space, I think I would choose to keep my 2 feet on the ground.
Stay right here at home. Martin, would you have a place that you would go?
Yeah, I think I would be with Renee. But
Stay right
I
here.
wish you all wonderful times.
And Shinting, where would you go if you could go anywhere?
I'll pick the asteroid, but I would not live there for sure.
Awesome. Awesome. So we've got a couple of questions here. The first one here is for Shogo. It looks like there's a size difference between the samples collected in the undisturbed regolith and those from the impact site. Does that have anything to do with the fragmentation of the material by the impactor, or could it imply something else about the distribution in the subsurface?
Yeah. Thank you for the great question. So actually, the size distribution looks similar at 2 sites. However, there are some additional large size pebbles in the second touchdown samples. So we don't know yet what this means. Those large pebbles could be fragments made by the projectile impact. We are working on that. Yeah, thank you for the question.
Thank you so much. Let's see, there's several questions here for you. Let's do one here. Have you studied the chemistry yet to see what kind of meteorite the samples match up with? Is there a type? And if there is a specific type, could you tell us a little bit more about that for people who aren't familiar with different types of meteorites?
Okay, yeah, that is also a great question. So now we are working at JAXA to pick up individual particles and then take photos and make a weight measurement, and also made some non-destructive spectroscopic observation. So we do not yet do any chemistry measurement, and all the operation is now made in a clean chamber, so without the exposure to the air. So we have very limited information currently. So we cannot say if Ryugu is similar to any kind of meteorite group, but I can say that Ryugu particles are really dark, so darker than typical carbonaceous chondrites.
Okay, okay. We've got several questions for you. I'm going to invite anyone who has questions about Artemis or our trips to the moon or about other things to also ask some questions here. And there's one here, Renee, for you. Can you give examples of investigations that the group recommended that require or can uniquely be done by astronauts? So are there examples of things that need astronauts require them or can uniquely be done by astronauts in terms of the investigations?
Yeah, so in the report, we were explicitly told by headquarters not to recommend specific instruments, but rather to recommend measurements, since there are multiple instruments that can address different types of investigations. But the types of measurements that we recommended, I would say, some of them are, you could probably argue that they need to be uniquely done by astronauts. And some of them are done either by astronauts or robotically, but still contribute to high priority science questions. So the prioritization was more focused, well, was sort of equally focused on whether or not this specific investigation addressed a high priority science question, and then whether or not the Artemis mission represented a uniquely enabling opportunity to make that investigation. So some examples, I'm just going from memory here, but one of the big ones was environmental monitoring. So monitoring sort of the environmental conditions on the surface. That can include all kinds of different things like temperature, some sort of radiation monitoring, solar wind impingement. It can include volatiles, the presence of volatiles, especially taken in tandem with sampling activities. So you can see, whether or not the physical act of gathering a sample liberates any volatiles. Seismic monitoring is one, and seismology is important not only for determining the internal structure of a planet, but also as an environmental factor itself due to seismic hazards. So if we're going to be building a base on the moon at some point in the future, we want to make sure that it is robust to whatever seismic activity may be happening. Other types of experiments can include something that we would call traverse geophysics. So that would include something like ground penetrating radar or gravimetry, in-situ type experiments. So I mentioned earlier, like a handheld spectrometer or X-ray fluorescence instrument or a camera. And now I'm trying to think back to the types of experiments that were done on Apollo. So there are a lot of different sort of geological, geophysical, geochemical, geomorphological. When you think about the regolith, you want to understand the geotechnical properties of the regolith, which has important implications, not only for understanding how regolith forms and is transported, but also important when we think about building roads or using regolith to build structures in the future for habitats. So lots of different exciting types of science to be done.
Thank you. And just to clarify for anyone who isn't familiar with a couple of these terms. So for volatiles, you're looking at things that would normally be gas here on Earth, like oxygen and carbon dioxide. And when you're talking about regolith, you're talking about what we would call soil on Earth, but it's not really the same thing on the moon. Do you want to add any corrections or other details to that?
No, I think you said it pretty well.
Okay, alrighty. There are several other questions for both of tonight's speakers, but before we continue with those, I wanted to kind of go around and let everyone share a little bit about something that they saw or heard today that was exciting for them. And I particularly want to pick on some of our microbloggers who have been attending all these sessions and talking about them. So I'll let you all decide who wants to go first. Who wants to jump in and share something that you saw or heard today that was particularly exciting? That
I'll go ahead and continuing our theme of Apollo. So I sat in on most of the lunar sessions, and I really liked a lot of the sessions that were about opening the Apollo samples that had been saved so that we could study them when we had new technology, more technologies, better technology since the Apollo era. And one of the things that I noticed was that a lot of people were using this type of analysis called X-ray computed tomography to look at these core samples, these like long tubes that have regolith that you were talking about and rocks inside them. And this, I'm gonna get to that in a second in the chat. So the X-ray computed tomography, XCT, looks at slices through that core, and you can see it in 3 dimensions and look at all of the different clasts or rocks in that sample and look at all of the different things in there so that they can pick out what they want to study maybe, or they can take sections of that rock and look at it in fine detail. And I thought that was a really cool thing. Jessica Valenciano, one of the people who was analyzing that one of those core samples, was looking at the cooling rates of individual crystals within one of the rocks in there. And I thought it was such a cool thing to be able to look into something that you can't maybe not see on the outside and try and understand where in an ancient lava flow this one rock existed at that one time.
Very cool. Thank you, Lori. Martin, did you have anything that you wanted to share about today?
Absolutely. I think I really think one of the more interesting things I saw today was actually Shogo's information about Hayabusa 2, and to see, because sample return happens so rarely, and it's wonderful to see the pieces that you have collected or that your team has collected, and I found that to be just incredibly inspirational, and looking forward to OSIRIS-REx returning information next year, and then eventually the work that can be done comparing the 2 bodies and with sample. But other than that, I mean, for the regular series of talks, also there was one of the things I like about LPSC is that you start going through the schedule and you wind up in places that you wouldn't think you were going to wind up before you started. And one of them was the exoplanet session, which was fantastic. I mean, I thoroughly enjoyed it from beginning to end. And I think my favorite talk of that was who did the piece on Oumuamua, Alan Jackson from Arizona State, who worked out that Oumuamua might just be a piece of nitrogen ice, or from an exopluto, and that fits a lot of the observations seen. I thought that was just a fascinating talk. So that I didn't expect when I started this morning. I did not expect that's where I would be, and it was great.
Awesome. Thank you, Martin. Shinton, do you have something that you wanted to say about today's sessions?
So also echo Martin, the Oumuamua talk is really great. And actually, I think they have a pair of papers. I just put a link in the chat that they just published today. So it's 2 papers. And basically they explained the possible origin of Oumuamua, which is not alien spaceship, but likely a nitrogen ice chunk that's ejected from an Pluto-like object. So yeah, so far I think I'm convinced it's not an alien spacecraft. And yeah, I also went to the atmosphere talk and I saw a really interesting combination of Mars, Titan, exoplanets. So yeah, definitely we have a really interesting combination of talks kind of crumbled together for each session. And yes, I also enjoyed the exoplanet session a lot. So yeah, but my highlight is definitely the Oumuamua talk as well. So yeah, that's it.
Thank you. Let's get to some of these other questions that have appeared. First of all, thank you, Shogo, for answering some of them about, so that you're going to begin a detailed sample analysis this summer. You answered quite nicely about why Ryugu was picked, what was special about it. Would you care to comment on that a little bit more so everyone can hear as well?
Okay, so the question was why Ryugu is so special for the solar system evolution. So I answered this way. So Ryugu is a C-type asteroid that could be a parent body of carbonaceous chondrites. So carbonaceous chondrites are special to us. So because they are not severely heated and contain hydrated silicates and organics, and then because of lack of severe heating, they still record the processes occurred in the very early stage of the solar system evolution. And the second, because they contain water and organics that could be the source of our ocean and ourselves. So those two reasons we decided to go to Ryugu. And actually Ryugu is a name of the dragon palace under the sea in the Japanese old folktale, because we are interested in the origin of the terrestrial ocean. So we named the asteroid as Ryugu.
Awesome. Oh, that's so awesome. That's cool. Renee, there's a question here. What's the endpoint for the lunar science definition team? Will the team be involved in science training of the astronauts, or will that effort be handed off?
So technically the science definition team is done. We produced the final report. That was our product that we were chartered to produce. And we then, handed it over to NASA to be used for forward planning. That forward planning does include training the astronauts and determining surface objectives and doing landing site characterization and landing site selection. And so in that sense, I would say, because many members of the science definition team are engaged in those activities, the spirit of our team lives on. And we hope to be able to contribute to every type of planning activity that NASA has, both more on the programmatic side and on the policy side, and also on the practical side, including things like training the crew.
Awesome. Thank you. And there's one question here. I'm going to see who wants to grab it. So Shabana asks, we study the North Pole and the South Pole of Earth with respect to the equator. What about other planets? Anyone want to tackle that one? Do we focus particularly on the poles? Lori?
Generally, when I'm thinking about mapping a surface, or when thinking about like the model of a surface, I'm thinking of the North Pole and the South Pole as their magnetic north and south poles, and then the equator falls at 0 degrees between those 2 points. And so the question disappeared, but I wanted to make sure I addressed the whole question. So when I think of the North Pole and the South Pole, it's those locations. We kind of also think about the North and South Pole on Earth a little bit differently, just because of historical mapping traditions. But other planets, that's kind of how we set up some mapping systems as well.
Yep. Go ahead.
I can add to that. Yeah. So the poles tend to be interesting places. On Earth and on Moon and on Mars, we have evidence or direct observation of ice, polar ice caps or polar ice deposits. On some of the gas giant planets, there's some weird activity that happens around the poles. I'm thinking of pictures of Jupiter. We see these amazing cloud patterns, and the outer gas giants have these really high inclination axial tilt, and so they appear to be rotating on their side, so their poles are actually near the position where Earth's equator would be if it were in the same spot. And so I think just from that perspective, the poles are scientifically interesting.
And that was the other point that I forgot to mention, was more about the rotation of the body as well. That's where asteroids also get complicated when you're thinking about mapping.
Absolutely. Absolutely. And then there's another question here that's a toss-up for whoever would like it, about water on Mars, about the composition of water on Mars. And Shabana says, it seems like they are highly volatile, leaving tracks that ends with pits instead of tapering to an end. I'm not sure if that is thinking about some of the marks that are on the sides of craters, or if that's something else. Does anyone want to talk just a little bit in general about water on Mars and the composition of that water? And
so my work on Mars is all focused on the deep interior. So I'm less qualified to answer that question.
We might have some participants. I know that we've got some LPSC attendees here. If any of you would like to chime in, you can either raise your hand and I'll turn on your microphone, or you're welcome to type something in the chat that we'll share with everybody.
Yeah, from my understanding, oh, Jennifer raised her hand, but like from my understanding, since I know some Mars people, is you definitely don't want to drink the water, liquid water on Mars for the flowing ones, because they're highly perchloride rich. In order to keep them as liquid under Mars temperature and pressure conditions. But yeah, like there's evidence of flowing water on Mars, which is still, like, I would say, a debated question, but you know, there's evidence for it. That's why, like, you know, but also just a reminder for everyone, there are lots of water if you want to go to the outer solar system. Lots of ocean wars, subsurface ocean, like Europa, Enceladus, Titan, even like Uranus moons, people are looking at if there's interior oceans inside the body. So like if you want to look for liquid water, you can go further than Mars. That's just a reminder to everybody.
Thank you. Awesome points. Awesome points. Whoever had their hand up, it went down and I can't see it now. So if you still want to say something, raise it again. There. Oh, that's just somebody on our panel. Yeah, Jen, please talk. Jen.
Yeah, no, I can address the water on Mars question. So that was the topic of my PhD research. So it's very near and dear to my heart. So for referring to the gully features that are on crater walls and pit walls and at the South Polar pits and some crater central peaks, those are very interesting because there's a lot of research going on. And if indeed they are liquid water, it means it was very recent liquid water. They're very young features. And so it has been a mystery because if they're young features, liquid water on the surface of Mars today is not stable. The pressure is too low and the temperature is too low. So you have this crazy situation where water would simultaneously, bubble away and, kind of evaporate into the atmosphere and also freeze. So you've got all these things going on. So you can't have the water stable for too long. But it turns out for these gully features, they're on the order of hundreds of meters in length, that you can have liquid water that actually can travel down and can make it to the bottom of that slope before all that water goes away. And what's really interesting about the gullies is that as the channels go down slope, they taper, they get narrower. So that's telling you that somehow if it's a liquid, you're losing that liquid, which makes sense for the case of water because it's, it's subliming and it's evaporating and it's boiling and it's doing all of these things. So it's a really interesting question, and we don't know the source of the water yet either. Is it melting snow? Is it, liquid water in an aquifer that's very shallow? Is it a deep aquifer where water is coming up? Is it somehow driven by the atmosphere? We don't know the source of that water, but it's a very interesting question scientifically, also relevant for human exploration if we're looking for water when we send humans. And it's very relevant for astrobiology because if there's, active sources of water on Mars today, that's an interesting place to go. And there are pits at some of the bottoms of those gully channels, which are very interesting as well. And there's several hypotheses for what that might be. And it could be, ice blocks that, kind of travel down in that chaos of water that's coming down. And then that ice is going to sublimate away. It won't stay. So it's interesting that in those pits, we don't see rocks. We don't see evidence of what made the pit. So it had to be something that made it and then disappeared.
Thank you so much, Jen. I appreciate it. And also, I don't know if we actually had you introduce yourself. Would you mind introducing yourself too?
Oh, sure. I'm Jen Hilman. I work at NASA Ames Research Center as a planetary scientist.
Thank you, Jen. So there was a question also, Bill asked about hydrogen in the dark and cold lunar craters. So I think he's talking about the shadowed regions, the permanently shadowed regions of the moon here. We see hydrogen there. How are we sure that it's water?
I actually think Jen would be the right person to answer that question too.
Okay.
Okay, so I'll take a shot at that. So correct, we make measurements of hydrogen from orbit. We do it on the moon, we do it on Mars, and we see enhanced hydrogen near the poles of the moon. And that's where it's very cold. So all of our theories tell us it's probably water. We know that there was water delivered to the moon and the Earth, you know, from comets and from asteroids and other sources, especially early in the moon's history. But the question is it actually water? And NASA had that question too. And so about a decade ago, we sent a mission to directly answer that question. And it was called the Eclipse mission, which stands for Lunar Crater Observation and Sensing Satellite. And so what we did, actually, I have it right here. Hold on. I didn't plan this, but here we go. So we wanted to touch in one of these permanently shadowed regions that hasn't seen sunlight in billions of years. We wanted to touch the ice, if indeed it was ice, and figure out what it was. So what we did is we launched with the Lunar Reconnaissance Orbiter, this was back in 2009 when we did this. And so what we did is the Lunar Reconnaissance Orbiter is still at the moon, still in orbit, still collecting data. It's fantastic. So it went and did its mission, and then we had Alcross. And what we did is this is the upper stage of the launch vehicle. It was an Atlas Centaur. And so we took this empty can at this point, all the fuel was gone. We drove it to the moon, and then we separated this little spacecraft off the top. We separated that, and we took this and we impacted the south pole of the moon in Cabeus crater, one of those big dark craters. We impacted it. When you do that, you kick up a big plume of dust, debris, etc. And then this little spacecraft had 9 instruments on it, and we flew through that plume to see what was there. And the bottom line is there was water ice there, among other things. So we actually did ground truth it in a way to make sure that it was water. And that's what's helping drive a lot of the science that Renee was talking about and a lot of the impetus for going to the south polar region of the moon with Artemis. So we're pretty confident that it's water ice.
Very good. Awesome. Thank you. Folks, you are welcome to continue asking questions. We've got just a few more minutes left while we are waiting for additional questions. Shugo, you had mentioned that JAXA is going to be sending a spacecraft to Phobos, one of Mars's moons, in the mid-2020s. Are you going to be involved in that?
I'm a member of the team, but not so contributing a lot. Yeah, because I have been busy in the Hyapsa-2 mission.
And how do you think the samples, what do you expect to be different about the samples from Phobos, from Ryugu? How is that mission going to be a little different?
Yeah, JAXA will go to Phobos to understand the origin of Phobos. It's not clear. So the origin of Phobos is not clear. So that could be an impact, could be made by a giant impact, or that could be a trapped pristine asteroid. So we will find the answer from the samples.
Awesome, thank you. And for the last few minutes, I'd like to, if anybody has additional questions, you are welcome to ask them. But while we are waiting for those, I'd like for each of you to think just for a second about what you would hope to know next year that we don't know yet. What questions came up this year? What questions do you have that you're excited about, that you're hoping in the next year's Lunar and Planetary Science Conference, we might know the answers? What are you looking forward to knowing more about? Or if you'd like, it can just be what is something that's really puzzling to you right now that eventually we'd like to know more about. It doesn't have to be something that you think we'll necessarily know in a year. So I'm going to let you think about that a little bit. And while you're thinking, I think I do have at least one more poll here for our participants. For all of our attendees, I'd like to know for our attendees whether you've come to this event, the Live from LPSC, before. So we're going to give those of you who are with us a few seconds to let us know whether you've attended Live from LPSC. Some of you are new. Some of you have done it in previous years because we've held it a few years. We didn't hold it last year, of course, because we didn't hold LPSC last year. Or whether you attended it earlier this week. I'm going to give you 5 more seconds to finish voting. 4, 3, 2, 1. And we've got a variety here. Several of you have come back and you've attended earlier this week. Some of you haven't ever attended it, and some of you have in previous years. And those of you who weren't sure, didn't know the answer, probably didn't vote. So anyway, And Ashley says last year would have been her first year. So yeah. All right. So for all of our speakers and panelists tonight, is there something that we've got a question about that you really can't wait to hear the answer to or to find out the answer to, whether it's something you're studying or something you're just curious about?
So I'm personally really looking forward to results from the first couple of Eclipse missions, which are set to launch between now and LPSC next year, assuming everything stays on schedule. And just seeing, how well those commercial landers work and seeing the exciting science that comes out of the instruments that they carry.
Awesome. And the Eclipse missions, we've mentioned them before, but just in case anybody missed it, those are missions that are they all landing on the moon? Are some of them orbiting the moon?
Yeah, so CLIP stands for Commercial Lunar Payload Service, and it's essentially a contract mechanism that NASA uses to deliver payloads to the surface. The first two are Astrobotic and Intuitive Machines, and they both will be carrying NASA payloads. And they will launch and land and execute some short duration missions. They're not designed to survive the lunar night, but they will provide data. I'm very excited to see how well they do.
Awesome. That's great. That's great. Thank you. Who else has something that they are looking forward to hearing more about?
Well, I'm looking forward to the results from Mars and looking at habitability and trying to understand our place in the universe and if there's life elsewhere and all the exciting science that comes along with that.
Awesome. Yes, yes. Thank you, Jen. Martin, you unmuted briefly.
Oh, yes. I was going to say the same thing about I'm looking forward to the year after Earth year one Perseverance results next year.
What Perseverance is going to discover. Fabulous. Shogo, do you have something in particular you're hoping to learn over the next year?
Yeah, next year, this is not, so I want to learn, but so we are going to report the detailed analysis of Ryugu samples next year. Yeah.
So knowing all about those beautiful pictures that you just showed us about, next year you'll have some more analysis of them. Awesome.
Yeah, chemistry, mineralogy, and petrology, everything. Yeah, organic geochemistry as well.
Oh, wow. Wow. And Bill says that they can't wait to see Pluto be a planet again, but also can't wait to see a helicopter fly on Mars. So, Shinting, what?
Yeah, so as a icy body person, like there's not gonna be much going on for next year for icy bodies, but in 15 years, Dragonfly will fly to Titan, and there will be a rotocopter with 8 wings flying a Titan. But this year, JWST, the James Webb Space Telescope, is supposed to launch October 31st. I know exoplanet is not the main theme of the conference, but fingers crossed for sure. But lots of words. Hopefully, we're going to discover words similar to like our words. I mean, maybe different, but who knows? Lots of exciting potentials for GWST for sure.
Absolutely. Lots of exciting potential things that we could learn, exoplanets, and even I think it might even be looking at some things in our solar system too. Lori, how about you?
So a lot of those Apollo Next Generation sample analysis presentations had the caveat that these are preliminary results or this is the thing that we're going to do next. And I'm really excited to see a lot of those. Some of them even said we're looking at how much water are in these samples or how much water do these samples have compared to other samples that were opened under different conditions. So I'm really excited to see the volatiles in different types of Apollo samples.
Awesome. We have a question from the YouTube channel. Someone wanted to know what the advantages are to commercializing space. Does anyone have an opinion or some thoughts on the advantages to commercializing space that you'd like to share?
I think for thinking of it, specifically as it relates to lunar exploration and Eclipse, commercialization can increase innovation and can also hopefully reduce costs to NASA. And we've so far seen a surprising response with, I think, 14 different companies who all got contracts to participate in the Eclipse program. So from that aspect, it's been pretty encouraging so far, and I'm really excited to see how it plays out. Of course, there are other aspects of commercialization NASA uses, but that's what I'm really most familiar with.
Awesome. Thank you. And we've got like 30 seconds left. There's a question about accessing Martian mineralogy, like the spectral library of minerals or CRISM data. I believe some of that is online. Does anyone want to mention where the public can see some of the Mars mineralogy data?
There are public online repositories of reference spectra that can be used and that are often used to compare to, say, CRISM data, for example. So one that comes to mind is Relab out of Brown University. That's a popular one. But if you search online, like there are, I mean, it's a reference data set that can be used.
Thank you. Thank you. And JMARS, I don't know if it has mineralogy per se, spectral data, but it's a great source of data as well for the public, JMARS, and for educators and for scientists. I am going to launch a final poll. And while this poll is launching, do any of our speakers and panelists have anything final that they would like to share?
Nothing for me. Thanks for inviting me, though.
Thank you all so much for joining us tonight. We really appreciate your time and your expertise and sharing your knowledge with us. And I hope you enjoy the rest of the conference, and we will see you again next year, if not before then. I'm going to give everyone about 10 more seconds to finish answering these 2 poll questions. We'd love to have feedback from everyone who attended, so that way we can continue to improve our programs. We're glad to have all of our attendees with us as well. If you weren't here, there would be no point in us doing this. So, and thank you all so much. I'm going to give you 4, 3, 2, 1, and poll. And reminder, tomorrow night, we're repeating it with new topics. Tomorrow night, we're going to hear a little bit more about Arecibo Observatory, as well as the rest of this week. So